This video file was recorded in Sabunji University during recitations for the CS204-Advanced Programming course as it was given in the spring semester of 2017.
For the second class, we will see something similar, but for a different purpose, of course. What we are going to do is the following. We are going to define a class for sets. You know what a set is? So let's say I have one set here. Let me call it set 1. And I have numbers here. Let's say 3, 5, 6, 9, 7, 8. I have another set. This is set 2. I have here numbers 2, 4, 6, 8, 7. Now I want to define some operators about this set. Unfortunately, the set type, data type, is not supported in C++, just like the complex number type was not supported. That's why we have to write it from scratch, from the beginning. And what we want to do is the following. I want to define a function, let's say plus, equal 3. Which is the same as saying set1 is equal to set1 plus 3. Or let's make it 2. What do you think I'm trying to do here? I want to add a new element to the set, a new integer, because those are integer sets. So after this operation, I will have 2 here. I will define my set, this is how I do it, that I cannot have duplicate elements. Okay, so if I want to put 3 here, I cannot do it because I already have 3. And of course, will put some other restrictions to those sets, namely for the maximum number of elements. I can make it 20, 40, or whatever. You can give it as a parameter, and you can take it during the call of the constructor. I can also do the following stuff. Set 3 is equal to set 1 plus set 2. And what do you think? What set 3 is going to look like? What I'm going to have? Come on, tell me. By intuition. Of course, this is a matter of definition. You can make everything. So?
2, 3, 4.
Just 2, 3, then?
9.
Yes?
8,
9. Although I have 8 twice, 7 twice, for the definition purposes, because of this is the way I define this set. You can define it otherwise, of course. I don't want to have duplicate elements, okay? Only unique numbers. So this is how I define set 3 equals, so this is set 3. Okay, so get the idea of the integer sets. So let's write a class from the beginning and let's see its usage here. First, remove the code that we have already seen here. And add from the IntegerSet folder, add all of the 3 files. First, let me run the program, and afterwards, we will see what we are doing here. Okay, I'm running the program now. Maximum capacity, let me make it 20, meaning the maximum number of elements a certain set can have is 20. Now I am entering the elements of the first set, namely I'm entering 2, 3, 5, 7, 8, 9. I press Ctrl Z and I'm over with the first set. And this is how I print. Integer set 1, I print the elements of the integer set 1. For the integer set 2, I have 2, 4, 6, 7, 8. They're not sorted. I mean, you can give them in any order you want. Oh, I'm sorry, because I didn't have system pulse here. so we didn't see the output. Again, 20, let me give 2, 4, 6, 7, 8. This is the first set. 3, 5, 6, 7, 8. This is the second set. And I print the second set. Then I define another set which is called IntegerSet 3, and I take the set 1 as a copy constructor to the set 3, meaning set 1, as you can see, and set 3 will be the same. Then I do the following stuff. Set 3 is equal to set 1 plus set 2. Basically, this addition operator is a union operator in mathematic terms. And afterwards, I do the following stuff. IntegerSet 1 is equal to IntegerSet 2 plus equal IntegerSet 3. So this is the result. And the result for IntegerSet 1. So this is IntegerSet 2 result. Of course, IntegerSet 1 result is the following. Since I have here IntegerSet 1 is equal to IntegerSet 2, but after evaluating this part here. So this guy is going to be done. It will be put to IntegerSet 2, and the result of IntegerSet 2 is going to be assigned to IntegerSet 1. Meaning that IntegerSet 2 and IntegerSet 1 will have the same values. And it is shown here. Now let's go and see the definition of the class. And of course, go with the operators one by one. Here we have something that we call operator overloading. Do you remember what was function overloading? Yes or no? So give me a clue, what was function overloading? Operators basically are nothing else but functions. The only difference is that when I write here operator plus, the name of the function is operator plus, but when I call it in main, I don't use this part operator. Otherwise, everything is the same. Okay? They are functions, but kind of different from classical functions because those are operators. So, you remember function overloading. Just to remind you, overloaded functions were the functions that had the same name, different parameters. Okay, number of parameters, or even if the number of parameters is the same, the type should be different, at least of one of the parameters. So here we are going to see operator overloading. We are going to say we have the same operator, but they are going to be overloaded. Namely, you see here I have operator plus as a member function. But here I have another operator plus, and yet another operator plus as free members, free functions. Where is there a difference? You see the difference is, yeah, they have two parameters also, but this guy takes one set and another set, while this guy, the second operator plus, takes an integer and a set. Okay? So let us go through all of this stuff now. That should stay there. So, this is class IntegerSet, because I'm dealing only with integer sets. What do I have here? The let's go with the private data first. What do I have as private data? My set. And this is a pointer to my set. Basically, this is a pointer to an array, and I put those data in an array. So my set is a pointer. Then what I have else? Max set size. You remember when I gave 20, meaning that I cannot have more than 20 elements in my set. Set 2 for the time being has 1, 2, 3, 4, 5 elements. This is the current number of elements. Number of elements. Those are integers. So number of elements. This is the private data. We have create, clone, and clear as functions also. So let me write them. So create, clone. And the other one is clear. And I'm done with the private part. Now let me go with the public part and explain functions one by one. In the public part we have IntegerSet the constructor with no parameters. IntegerSet, this is another constructor, but it takes an integer parameter. Is this a copy constructor or not? What do you think? It takes an integer, and the integer basically is the set size. And I have this one. This is the copy constructor, because copy constructor should take as a parameter an object of the same class. So I have IntegerSet, and I'm taking as parameter another object of class IntegerSet. A reference to it. Of course, I have the destructor here. I'm destroying everything that is dynamically allocated, basically, in this case. I have operator equal to make two sets be equal. Then I have the operator smaller or equal. And we will see how we are going to define it. So operator smaller or equal. I have operator plus. Well, this operator plus takes an integer. Basically, I'm adding an integer to the operator. And this is member function, remember it. I'm taking get number of elements to return the number of elements, because they are private. So get number of elements. I'm writing it like this. Get what? Get element. So what I'm doing here, I'm going to keep those elements here in an array, which is not sorted. So I have 4 here, 2 here, 6, 8, and 7. Okay? We have indexes 0, 1, 2, 3, 4. This function, get element, and this array is a private data. Okay? So I'm going to use this index to return the ith element. So get element, and I'm sending the indexes parameter. Get element. I'm sending the indexes parameter. What else do I have? Exists. It's a Boolean function that turns true if a certain number already exists in our set. This is interesting here. I have 3 function prototypes. And I'm going prototypes because I declare here, I'm going to define them afterwards. I have the outstream, operator outstream. And those are not member functions. That's why I'm writing them in a separate place. Operator ostream, operator plus, which is not the same as this plus. This plus takes what? Set 1, set 2. 2 sets. Set 1, set 2. I have operator plus again. It takes an integer and a set. Integer set basically. So operator plus. One, two, 3 operator plus. One of them is member function. 2 others are free functions. And finally, what do we have? Operator plus equal. It takes left-hand side and right-hand side 2 sets. Set 1, set 2. Okay, let's go see the definitions of those 2 guys. First, let me start with the constructor, IntegerSet. It's not that one. Namely, when I declare a variable of IntegerSet class, I make this pointer to point to a null. Maximum set size is 0, and the number of elements, current number of elements, is 0. This is the constructor. It's straightforward. When I declare a variable and I pass an integer as parameter, then this is what I do. Max set size is the size, so this integer here, max set size, is set to the size. Number of elements is 0, because initially I don't have any elements. And my set is equal to new integer max set size. Can you tell me what I'm doing with this stuff here? Okay, so my set was a pointer to an array of integers. And how many elements I'm going to have? I'm going to have maximum set size of elements. Okay? So I reserve a memory with maximum size of integer elements for that particular array. And my set is pointing to that array, to the first element of that array. So IntegerSet was done. Remember, when you declare a variable without IntegerSet variable without parameters, you call this constructor. When you declare it with an integer variable, a parameter, you call this one. Okay? Now let's go and see with when I call it with another integer set. Basically, it's when I call the copy constructor. I call the function create clone. So let's see what create clone is doing. Let me find it first. So this is create clone. As you can see, create clone takes a reference to another integer set. And for those that are confused with this const means that this parameter that I'm sending is a constant one. I cannot change it. Okay, so I want to create a clone, a copy of this parameter, which is called copy. What I'm doing? Firstly, so this is my, let's say I'm the guy, the object that is calling this copy, that is calling this create clone function, and takes the copy as parameter. Okay. What I do is the following. If copy my set is equal to null, then I do the following stuff. My set is null, meaning I don't have any array. Maximum set size is maximum set size of that guy. Number of elements is equal to copy number of elements. Okay. Otherwise, if my set is not null, meaning that if the copy constructor has some elements there, so this is the case when I call copy. If it has no values, then my pointer points to null, and I don't have any values. However, if the copy has values, then this is what I'm trying to do. My maximum set size is the maximum set size of the copy. Number of elements is the number of elements of the copy, and then I'm setting this pointer to point to an array of max set size, and I'm taking the elements of the copy one by one. This is how I do that. So my set of I is equal to copy my set of I. Okay. So if the copy has elements 3, 5, 7, 9 to its array, then I'm copying the same elements to my array after I reserve the memory. Is this clear? Yes or no? Okay. So this is the create clone function. I make the exact clone of the copy. So we have seen the create clone. And what the copy constructor is doing, since I create the exact clone, where is the copy constructor? Yes. This is the copy constructor. Basically, here, I call the create clone function sending the same copy as parameter. So this is the copy constructor. What do we have else? Exists. Let's see the operator exists. This returns true if a certain number exists in this array here. Otherwise, it returns false. So what I'm doing here, I start from 0 till the number of elements and check whether my set of I is equal to the element. I take, as a parameter, I take an element of type integer, and I check whether my set of I is equal to element. If any of the elements of my array is equal to the element, I return true. Otherwise, I return false. So this is the exist function. Now let's go with operator. Well, let's see those guys. Get number of elements, very easy. Return number of elements. So I'm returning the number of elements. Get element, since my set is a pointer to an array which is private, I return my set of index, okay? This is get element. I'm returning a certain element with certain index. Let's say if I want to return this 8, I send index 3 and I return it with this function. So this is get element. What else do we have here? Operator plus. Let's find it. Okay. I'm creating here, this is for adding new element to the list. The element that is going to be added is an integer. I'm creating a temp, a new variable to temp, and I'm sending of type IntegerSet, and this is what I'm calling here. This what was. So let's say this guy has a memory of 1010 again. Let's make it the same. And this is pointing to this one. When I'm sending this, I'm sending start this. I'm sending the whole box. So basically, I'm creating a copy constructor. That means I'm creating a new object, which is called temp, which is exactly as myself. So if I'm on IntegerSet and I have all of those functions, then I'm creating another temp that's exactly like me. Basically, this is another clone. So I call the copy constructor, remember, the copy constructor calls the create clone function, and I have a clone of me. Now I'm trying to add an element to myself. And what I'm doing, actually to the temp. Because it's not plus equal, but plus. If temp number of elements is equal to temp max set size. If the max set size is maximum number of elements is set to 20, I cannot add anymore. That's why I'm going to say the set is full, cannot be added. However, if I want to add an element that does not exist, I'm checking it here. If the element exists, I'm not doing anything. I cannot add a copy of it. However, if the element does not exist at the temp that I created, then this is what I'm doing. Temp my set number of elements is equal to element. The number of elements gives the current number of elements in the list. Okay. So although it looks like this, I might have empty slots here. So here I have 5 elements, but maximum set size might be 8. Okay. That's why I'm checking. Do you have place here and whether the element that I want to add exists. If I have place and the element does not exist, then number of elements, let's say, was 5 here. So I put it to the 5. So number of elements was 5. Let's say the variable that I took as a parameter, this element is 10. So I put 10 here. And then what? I increment the number of elements. From 5, it's pointing to 6. Meaning I have 6 elements. Okay? And finally, of course, if I don't have place, I print this stuff. I'm returning temp. Why I'm doing this stuff? First, did I change myself? Let's say I'm the IntegerSet function. Did I change myself or not? Can you tell me? Yes or no? No, I changed my copy. Okay, I created my copy, which was temp, and I added an element in temp. Okay, because this is not plus equal, this is only plus. And finally, I return temp. Okay, so I added an element to the copy of myself and return it. Why did I return it? Because of cascading equal operators. Okay, I might say set 1 is equal to set 2 plus 3 is equal to set 4 plus 5. Plus equal 5, something like that. That's why I'm returning this. This is operator plus. Basically, I'm adding an integer element. Now let's go with something else. Operator equal. Can you find the operator equal here? Okay, this is it. Very easy. Can I say I am equal to myself? Yes, I can do that, but I don't have to make any changes. That's why I'm checking. If this, meaning I, myself, is not equal to right-hand side, then return this, okay? If I try to be equal to myself, I don't have to do that. I'm already equal. But if I'm not equal, what I'm doing, I'm clearing myself, and I'm creating clone of right-hand side for myself. I'm becoming the clone of the parameter that I'm sending. Now let's see what clear function is doing. So clear and operator equal. The clear function, you remember when I started first, I dynamically allocated the memory for my set, and I'm deleting that. And I set my set to be null. So when I want to be equal to someone else, which is the right-hand side, I delete everything about me, okay? And then I become the other one. How do I become the other one? Again, I call the create clone function. So operator equal calls the create clone function because it creates a clone. Again, operator, the copy constructor, again calls create clone because it's doing the same stuff. Okay? That's why I keep it private. Is this clear? I know it's a bit confusing, but I think it's doable. Any questions till now? Yes or no? How many of you understood this? But be honest. None of you? How about 70%? 70%, okay. How about 55.5%? 55.5, okay. If there's any problem that you have, please stop me and ask me about what about this one? How did we do that? Okay? Shall I continue or do some repetition of this stuff? I know it's hard because you need some time to digest it. Okay? So if you again watch the videos or go through the code, after 1 week it will be okay for you because this is how the brain works. Even when you sleep, it works. And I'm not joking. I mean, it processes this data. Okay? That's why the earlier you go through these codes, the earlier you will understand them. It needs to be digested. Okay? I know it's confusing. That's why we have only 2 samples for today. But it will be clear, I hope. Okay. Operator smaller or equal. Where is operator smaller or equal? How I define operator smaller or equal? I take as a right-hand side operator another integer set, and I define this the following way. If the size, I mean, if I am, it's like this. I am this guy that is calling this function, and this is an integer set. And I'm trying to see whether I am smaller or equal than this right-hand side. And I defined smaller or equal to be like this. If the number of elements, the number of elements that I have, is greater than the number of elements that this guy has, then I'm returning false. Okay. However, this is one. Another one. If I have an element that this guy doesn't have, I also return false. This is how I define smaller or equal. It might not make sense, but you can do whatever you want with your code. This is my definition. You can come up with another definition. That's why I go from 0 to number of elements, and I check whether an element that I have, this guy doesn't have. If I have an element that this guy doesn't have, the right-hand side, then I return false. Otherwise, I return true. Meaning if I have smaller number of elements and all of the elements that this guy has, that I have, this guy also have, then I'm really smaller or equal to that guy. So I return true. Okay? This is the function. Operator smaller or equal. Again, very briefly, like in a couple of minutes or so. IntegerSet, when I'm creating myself, I put my set to be null, max set size 0, number of elements 0. When I take an integer as parameter, when I create myself, I just allocate, let's say if I give 20, I allocate 20 using the new command 20 elements of this array, and I put max size to be 20. Number of elements initially 0, because I just created myself. What else? Get element returns the element. Get number of elements returns the number of elements currently in the set. Get element returns the index, because this is private. We cannot access by this my set. So I'm using this function to get the element that I want. Create clone. What it is doing is the following. If already I have elements in my set, and I take the right-hand side, this is myself, and I have all of those functions. Create clone takes another guy. Let's say this is another integer set. What I'm doing is the following. If I have elements, I'm deleting it. Then I'm creating a new array and put the elements of this guy to my array. This is what I mean by create clone. This is used at operator equal. Equal means I take another guy and I want to be equal with that guy. Okay? But sometimes I might say myself is equal to myself. That's why I don't have to do the processing stuff. But if I'm not equal to myself, I want to be equal to someone else, then I'm doing the same stuff. I'm calling the create clone function. The copy constructor is basically the same. So integer set with another integer set makes me equal to that one. That's why we create clone, integer set, and operator equal are doing the same thing. Basically, those two guys call the create clone function. What else do I have? If I want to add an element, an integer, but not to myself. I just want to create another me, so this is me. I create a clone of myself, and in this clone, I add an element, and then I return it. So this is what the operator plus is doing. Okay? But I'm not changing myself since this is not plus equal. Okay? Exists returns true if a certain element exists at my array. This is it. Very simple, basically. And everything, when I said I had all of those functions that are only for me. But every other human being or every other integer set has those functions. However, I have other functions, and those are public functions. Those are operators. Okay, everyone can see them. They are not a member of myself or yourself. These are the same for everyone. Now let's see how we are going to deal with those guys. First, let's go with operator plus. But you remember, you might say, okay, I had already operator plus. Yes, we had it with an. How did it work? I had myself and an integer. Okay, so integer set and integer. But this guy operator plus are two sets. So I have one set, another set, okay, and I'm creating a third set. Let's say this is the third set, which is the union of those two, and I'm returning this guy. This is operator plus. How it's working? This is how it's working. So operator plus. The result, I will have the final result in this variable, integer set variable. I'm calling the copy constructor set1. So basically, result is equal. Okay. Those are two guys. This is set1. And I'm saying result is equal to set1. Okay. And I'm taking another one. I say my second set is equal to set2. What I'm doing then, I'm taking the values of the second set, so those two are equal. This is the result. This set 2, I'm taking the elements one by one of the second set and adding them here. And when I add them, you see I'm getting integers here. So basically this plus function here calls the member function plus that we already defined. Okay, so another overloaded function calls another overloaded function. One overloaded operator calls another one. So I have the result here, take elements of the second set, put them one by one here, and finally when I'm finished, I return the result. Is this clear? Okay. We have another function plus, just to make you confused, but I have here an integer set. So one element is a normal integer, let's say 3, and I have a set with many numbers inside. So where's the difference between this guy plus and that guy? Can you tell me? So I have here 2 batteries. Let's say this is number 2. And this is the set. I have some numbers here. 3, 5, 7, set of numbers. What is the difference between operator plus and the previous one? At operator plus, this was a member function, 1. And when it's a member function, the left-hand side is always itself, meaning the set. So left-hand side is the set, and the right-hand side is a number. Here is vice versa. Right-hand side is a number, left-hand side is a set. Okay? Meaning that if I say like something like this, set 1 plus 3, I'm going to call this function. But if I say 3 plus set 1, then I'm going to call this function. Okay? Because here, left-hand side is an integer, right-hand side is a set. Now what I'm doing here, very easy, and I want to return result. I define another integer set, which is result. It takes this set as copy constructor, basically constructs a clone of this set. So result is, for the time being, same as the set. I'm adding this element to the result. I'm assigning it with operator equal to the result, and I'm returning the result. Okay? So those were the 2 overloaded functions. Operator plus, the other operator plus. Let me check operator plus equal. What I'm doing here is very easy. Can you tell me what I'm doing here? Plus equal. It's same as saying left-hand side is equal to left-hand side plus right-hand side. If this is the left-hand side and this is the right-hand side, when this function is finished, I want this guy to have all of the elements inside. Okay, this plus other element. That's why to the left-hand side, I add the left-hand side plus all of the elements one by one from this set here. Okay, and finally I return left-hand side. Can you tell me why? Because I might use something like this. Set 1 is equal to set 2 plus equal to set 3, which is same as writing set 1 is equal to set 2, which is equal to set 2 plus set 3. Okay. And finally, we have the operator output stream. This should be a bit easier for you. And we are done with operators. We can proceed with the examples. How do I print a certain set? Initially, I open the bracket, I print it. If the number of elements is not greater than 0, I print this one. So I open the brackets, the parentheses, and close them. I don't have any elements. But if I have elements, I open the parentheses, and I print them one by one, separated by comma. And the last one, I don't print comma at the end. I just close the parentheses. This is it. And of course, I return the output stream, because of cascading purposes. Okay? I might print an integer, a complex number, a double, a float, a set, another set, and so on. That's why I'm printing it. You can see that as a parameter, I take this output, which is returned after printing this stuff, and the set, which I want to print. I think it should be constant set, because I don't want to change it, but we're not changing it anyway. This is all about the free member functions here. Those are free member functions, are not inside of the class, are common for all of the objects. Now let's go and see the main function, what I'm doing there. So this is the main function. Very easy. Let me run the code, and simultaneously let me show its output. So, please enter maximum set capacity, and I'm entering the capacity to be 20. Then I'm here, IntegerSet 1, I'm creating a new set, maximum capacity. I created another one, IntegerSet 2, with maximum capacity of 20. Now I want to enter the elements of set 1. Please enter the elements of set 1. And you should press Ctrl Z after all elements are added. So I'm adding 2, 4, 6, 7, 8. I'm done. This is it. This is how I add elements, by using the plus operator, which was a member function. Afterwards, I print set1 with this cout, and here I have the output. Just in case that I don't want to have mistakes, I clear the cin, and I repeat the same procedure for set2. So now I'm entering the elements of set2, 3, 5, 7, 8, 9. Control Z, I'm done. So I print IntegerSet2. Now I define another IntegerSet3, which is a copy constructor, takes IntegerSet1. Basically, IntegerSet3 is going to be the clone of IntegerSet1. After doing that, I print IntegerSet3 here, and here I have it. IntegerSet3, after IntegerSet3, blah, blah, blah. So set1, which is here, and set3, which is here, are going to be the same. Afterwards, I do some manipulations here. I say IntegerSet3 is equal to IntegerSet1 plus IntegerSet2, meaning it's the union of set1 and set2. So IntegerSet3 after IntegerSet3, blah, blah, blah. The union of set1 and set2 is this one. Afterwards, I do this operation here, and I print the output. This is the output that I print, integer set3 after blah, blah, blah. I do this operation here, and I print the output for integer set2 and integer set1. This is it. Should I go and debug the code or not? If someone says yes, I'll do it. Yes or no? Just let's see which function is called where. Very briefly, I just tell you what you should do at your home. I'll start from here. So please enter blah, blah, blah. I don't want to do that, so debug, step over. Again, debug, step over. Now I asked to give the size, it's 20. Now here, let's see what I'm doing here. Maximum capacity is an integer. That's why when I go to step into, I'm calling this constructor that takes an integer as a parameter. Let's go through it. I'm setting the size. I'm creating an array dynamically. Number of elements initially 0. Okay, then I go to this one. It's doing the same, exactly the same. Now here I'm reading the elements one by one. So I'm giving 2 here. Then I'm giving 5. Then I'm giving 7. And this is it. I'm going to finish here. Control Z. Then I'm printing the set. Let's see how I'm doing the printing stuff. Step into. I'm going to operator cout. And I'm printing them one by one. Output. So I have the brackets only right now. And I'm printing the elements one by one. You see? I'm printing 2. I'm printing 5. And I'm printing the last element and close the brackets. 7 and close the brackets. Okay? Go step over. I'm continuing, seeing clear. I read the data for the second set and so on till the end. Okay? I don't want to take your time anymore. I know that it's complicated. If it's necessary, we can make an extra recitations for this stuff. If you cannot figure it out from the video. If you want, you can go now. I'll take like 3 or 4 more minutes to explain the homework. Which is, if you understood this stuff, it will be easy for you. So, this is the homework. By the way, the main is given. What you should do, this is the main. Okay. So you're going to define a class which is called scatterplot. Plot actually, class plot. And it has some operators like plus, equal, and you're going to see other 9 operators in all. Basically, you should write the header and the CPP file. Everything else is given. What we are talking about here, this is the class we are talking about. This is the scatter plot. Of course, you should not graphically display them, but you keep points. Namely, you keep the x and the y coordinate of the points. And you should have the default constructor, deep constructor, and destructor. The point, you should have the operator ostream for printing. You should have this operator plus, another plus, another plus. But read them carefully because they are not the same. Namely, if we have 2 points with the same value of x, then the y should be the average. Keep it in mind that x is always integer, y is double. Okay? So I have here 2, 3, and I want to add 2, 6. But their x values is the same. That's why x will be the same, but 3 plus 6 is 9, divided by 2 is 4.5. That's why I'm going to add 2 and 4.5 as a new point to this plot. Basically, I keep those points in an array, and I add or delete them, just like it was the case with IntegerSet. But we don't have a set here, we have a point. Another plus, meaning I can add 2 plots, a point and a plot and a point. Minus, I can delete a point. Operating assignment, equal, if 2 plots are the same, you return true. Plus equal, minus equal, okay? This is the sample run that you should have here. Initially, you enter the points 1, 1, 3, 3, 2, 2, and plot 1 has those points. Plot 4 is equal to plot 1 plus 5, 3, meaning to those points I add the point 5, 3, so plot 4 is going to be this much. But I don't change plot 1, it's the same, because it's not plus equal, it's plus only, and so on. Basically, this part is going to be repeated from main. You just have to define the class plot, nothing else. Any question? If you don't have question, you can send me an email, or after the term break, if you're not okay with operators, overloading, and classes, we can make an extra recitation, but I need at least 5 of you. This is all for this week. Have a nice break. See you in 2 weeks.